Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to get an introduction to complex numbers, and also we're going to take a look at how to add and subtract complex numbers. So let's begin. So why don't we first begin by defining exactly what a complex number is. And if you open any intermediate algebra textbook, you'll see something along the following that gives you the definition of it. When you have A, which is of course going to be any real number, plus bi, which you know that bi is just an imaginary number. When this combination is seen together, they make a complex number. Now again, the purpose of imaginary numbers is when we have a situation in which we have a radical that is a negative. Of course, this is not technically possible, but for the sake of being able to manipulate things mathematically, we have this as an option in terms of algebra. So now that we understand what it is, we're going to cover how to add and subtract numbers that are complex in nature. Complex in nature. So now at first this is not going to look complex because it won't have a real number, but just trust me, work through this as it will, because another way to think about it is like if a equals 1. So take a look at this and just follow my thought here. Let's say we have the square root of negative 8 plus the square root of negative 32. Now this does not look like it's a complex number, but again, we could just put a 1 out here as follows or whatever, and then it will fit the pattern, if you will. But the main thing is that we have this plus sign in the middle also as well that kind of indicate that it can be a complex number. Because what's going to happen is that as we work through it, we're going to end up removing the add sign here and end up with something of a complex number, if you just follow my thoughts for a second. So the first thing we want to do is we want to take care of this negative number by making it an I. So we end up with the following. We end up with the square root, oh that's kind of dark there, let me give you a stronger contrast. We end up with the square root of 8, positive 8 now, and then I on the outside of the radical, plus the square root of 32, and again we put the I on the outside of the radical. That's the expectation there. Now we just kind of factor things as follows. So we know that the square root of 8 can also be seen as the square root of 2 multiplied by the square root of 4, and then of course you have your imaginary number on the outside, and then over here we have again the square root of 16 times the square root of 2, and then we have our imaginary number on the outside. So we're getting close here. Now it's just a matter of reducing and simplifying things. So we know that 2 is going to become, the square root of 4 will be 2. We know that. So I'm going to put the 2 on the outside. I still have my square root of 2, so I put that here, and then I have my imaginary unit right there. Then we're going to do plus the square root of 16 is 4, and then we have the square root of 2, and then we have the imaginary unit right there. Now because we have the same bases, if you will, inside the square roots, we can now just add things across because it's square root of 2, square root of 2. And so we end up with the final answer that is as follows. 2 plus 4 is going to be 6, and then we still have the square root of 2, and then we have our imaginary unit right here to complete our answer. So this is kind of how it works in this particular situation. This is a very, very simple example where we started with 2 imaginary numbers, and then we ended up with a final answer at the bottom that has an imaginary unit to it and also has a constant outside of it. Now let's do another example. This one is more in line of our initial definition right here on this page. So here we go. Now we have something that is kind of what you're expecting. 2 plus 7i plus 4 minus 2i. Now this is more in line, like I've already said several times, with our definition for a complex number. We have here, we clearly have an A. This is our A. We have our BI here, etc. And what we need to do now is figure out how do we handle this. Well, what we do here is we combine like terms, or for those of you who are a little bit more comfortable with mathematics, we use the associative property, which means we just combine the like terms. So this is what we end up doing. we take the 2 and the 4 and we put them together inside parentheses. 2 plus 4 plus, and then we take the 7i, put it over here, minus the 2i, like so. So we combine like terms. And so now 2 plus 4 is 6. We still have the plus here. That doesn't go anywhere. And then we have 7i minus 2i. That's going to be 5i. And this is our answer. Again, this is a pure, or not a pure complex number, but this is a complex number. And there's lots of different, real imaginary numbers, pure imaginary numbers. That's something to talk about at a later date. But for right now, you can clearly see that we have a complex number right here in our final answer as we combine the like terms in the previous step. So having said that, why don't I go back and review what we talked about today and then conclude this video. So in this video, we learned about complex numbers. A complex number has two components to it. A real number, which can be any real number, and an imaginary number, which is a number with an imaginary unit connected with it. And remember that we use the imaginary numbers often are associated with radicals when you have negative radicals. And so our first example was not quite what you were expecting, but it's kind of showing you the thought process behind how you add two imaginary numbers. That's what we're looking at here. And so how do you add these two imaginary numbers? Well, you got to go through this process right here, where you have to break things down and find the factors. And when you have the same base, like right here and here, you can then finally finish it off. The second example was kind of more in line of what I was talking about when I was speaking about complex numbers. And so in this particular example, what you do is that you combine like terms, as you can see in the example right here, to complete this. And so you can clearly see that this is my real part right here, and this is my imaginary part right here. And when this happens, you are done. So I hope that this video was useful for you as you watched it. I want to thank you for watching. Take care.